It's 5.1, day 2, using the fundamental identities. We're going to just practice some more of the simplifying of expressions. So you want to make sure you have your goal sheet, your formula sheet out. And first problem that we'll do is we want to simplify this expression down. And the hint is we want to factor it. Factor, factor, factor. Some textbooks change the factoring so that you don't have to worry about that trig function in there. So what they call that method of factoring is U substitution, where they replace every cosine of x with the letter U. So it's a little easier to recognize the factoring methods. So remember when we did factoring, we had methods of difference of two squareds, trinomials, we did the AC method or the chart method. When there was 4 terms, we did the grouping method. Those things come back into play. So if I were to replace each cosine of x with the letter U, this is the trinomial that I'm going to factor.
Do we have to substitute the
You don't have to. No, you don't. It's not required. You could just factor it as it is like this. So what we want to do with this trinomial is either use like the chart method. We say what are the factors of the left and right side, add them together, and then you may want to check by FOILing it back out. So when we FOIL this back out, we want to make sure that my first terms multiply to give me the value of 1. So we want to split up this first term in only multipliers of 1 is 1 and 1. Then my last term, when I multiply the last terms together, they have to combine back together to give us u to the 4th. So you could split up as u squared times u squared, or u to the 4th times u to the 1. You only have 2 choices. So we split up as u squared and u squared. Then you have to figure out what kind of signs should go in there. Well, you want your middle terms to combine to -2. So if I were to FOIL this back out, maybe you can just do it in your head. 1 times 1 is 1. 1 times -u squared, -u squared, so there's one of the -u squared. Multiply again, -u squared, so now we have -2u squared, and then -u squared times -u squared is a positive u to the 4th.
use greatest common factor?
There isn't a greatest common factor in this trinomial. There's nothing in common with all 3 terms.
Can't you split the cosine to 4 to cosine 2 of x and cosine 2 of x?
Yeah, but there's not, you have to have a greatest common factor with this term too. So now we just go back to what u represents. U represents the cosine of x. So now you're taking this 1 minus u squared, replace that trig function back there. So it's 1 minus cosine squared of x. And then 1 minus u squared again is 1 minus cosine squared of x. Now we try to reduce it down. Are there any identities on your gold sheet that you can replace it with? Very good. The Pythagorean identity pops into play for both of them. Both of these parentheses are the Pythagorean identity. So I can replace both parentheses with sine squared of x. And now we just clean it up. Sine squared of x times sine squared of x is sine to the 4th of x. And there's our final answer.
Where does this stuff come into play?
Like real life.
Yeah. Like, is there going to be any numbers in this chapter?
There will be. What we get into tomorrow is we're going to give you equations with trigonometry in it, and you have to solve it for x. So it's coming back into, can you reduce down today and yesterday's topics to tomorrow solve the equations for x? So you're going to go back in and getting angle measures again. All right. More factoring. And the hint of factoring is the difference of two squareds. So do you remember the difference of two squareds? If you have a squared minus b squared, you can factor it as a minus b times a plus b. Do I have that scenario here with sine to the fourth of x minus cosine of fourth to the x? I have two terms. They have to be raised to the second power. In this case, they're raised to the fourth power. So how do we factor this expression?
A squared minus b squared.
Yep, a squared minus b squared. So this would be, how would I split up the a squared? Sine squared of x and sine squared of x would FOIL back to sine to the fourth of x. What's going to be my b part? Cosine squared of x, cosine squared of x, and the signs in between them, plus and minus. Now, any identities pop up there? Which one's the one? This one right here? This is the Pythagorean identity, which sine squared of x plus cosine squared of x equals 1. And then we have is that a Pythagorean identity? So then we just have sine squared of x minus cosine squared of x. Okay, hint. Factor by grouping. So we have 4 terms. Grouping method says takes 2 terms that have something in common and take out the GCF. Then take another 2 terms, take out the GCF, and both parentheses should match up. So what might we want to group together? The first 2 and the last 2. And usually a lot of textbooks, they usually set them up with it being in that order already. So we're going to group the first 2 terms and the last 2 terms. Now, what is the GCF of the first group? Cosecant squared of x. So when I take out a cosecant squared of x from the first group as its GCF, what am I left with? Cosecant of x minus 1. In the second group, what's the GCF? Remember, I want the 2 parentheses to match up.
-1.
Take out a -1. When I take out a -1, it's going to make that negative cosecant of x a positive. That's going to make that 1 now a negative. Do the parentheses now equal each other? Yes. So that's my new GCF. There's my GCF. What's the leftovers? What's the leftover stuff? I have to take those parentheses out. Cosecant squared of x minus 1. Now, any identities? Let's go back to Pythagorean identities again from yesterday. remember that you may want to rewrite all of these. This one in the bottom, 1 plus cotangent squared of u equals cosecant squared of u. How do I get that 1 to the right side? Minus it. So to solve that for cotangent squared of u equals cosecant squared of u minus 1. Is that right side in there? Yep, so let's go back to our problem. We're going to replace that parenthesis with now cotangent squared of x.
Sure, it's not.
Yeah. That's fine. Alright, so now here's the Pythagorean identity again. Which is cotangent squared of x. And if you try to write it all as sines and cosines, nothing's going to cancel out farther from that, so you're done.
Doesn't have a side cancel thing?
Pardon?
Actually,
Nope, it's not a Pythagorean identity because it's not a cosecant squared of x. Let's stop recording.